Hi everybody, today we are going to talk about multiplying polynomials again, and we're going to look at a couple of special cases. So, these two special cases occur all the time. There are special patterns for them, but it's just as easy to use FOIL if you get confused on any of these, just like any other multiplication of binomials. So here's the first one. Now this is a pattern, you really should know this pattern because you run across it all the time. And you run across it both directions. You run across it from here to here, and you also run across it a lot from here to here when you're factoring. So, a plus b times a minus b ends up being a squared minus b squared. Now we can actually prove this pretty simply. Okay, so if I take this and I FOIL it, first would be a squared. Outside would be minus ab. Inside would be plus ab, and last would be minus b squared. And then look what happens here. Negative ab plus ab just cancels out. So this goes away, and I'm left with a squared minus b squared. Okay, so there's that. So we've proven that, so we can do that on this one. X minus 4 times x plus 4. This would be one you should just be able to look at it and go, you know what, that's going to be x squared minus 16. Okay? Then again, if you don't see that right away, you can always take this thing and FOIL it. So x times x would be x squared. X times 4 would be 4x. Negative 4 times x would be minus 4x. And negative 4 times positive 4 would be minus 16. And then, like I said, these two are going to cancel out. And I'm going to get x squared minus 16. Okay? So it confirms the answer that we got before using the pattern. Okay, here's another one that you can use. 2x plus 3 times 2x minus 3. So again, if I use the pattern on this thing, I'm going to go ahead and say, well, if this is a and this is b, so this is a plus b, a minus b, then this should equal a squared minus b squared. So a squared is going to be 2x squared minus b, which is 3 squared. Okay, so this should be 4x squared minus 9. All right, let's go ahead and use FOIL on this. So first, 2x times 2x would be 4x squared. Outside would be negative 3 times 2x would be negative 6x. Inside would be 3 times 2x, which would be positive 6x. And last, 3 times negative 3 is negative 9. These cancel out in the middle, and I get 4x squared minus 9 again. Okay, so either way, I get 4x squared minus 9. Let's take this stuff and move it up a little bit so you can see it better. Okay. So the next pattern is a plus b squared. And you can use this formula, a squared plus 2ab plus b squared, to figure that out. Okay, so you can prove this pretty simply. If you take a plus b times a plus b and you FOIL it, first a times a is a squared, outside is a times b, inside is also a times b, and last is b times b, which is b squared. And you combine your like terms here, you get a squared plus 2ab plus b squared. Okay, so that's how you get the formula. So here I got x plus 3 squared. So I could say, oh, well, let me see. Here is my a and here is my b. And so this is going to be a squared, so that would be x squared, plus 2 times a, which is x, times b, which is 3, plus b squared, so that would be 3 squared. Okay, so this would be x squared plus 3 times 2 is 6x plus 9. Okay, so there's my answer. Now, the other way to do this probably easier is to just write this out, x plus 3 times x plus 3, and FOIL it. X times x is x squared. Outside is 3x. Inside is also 3x. Last is 9. 3 times 3. Combine your like terms. X squared plus 6x plus 9. So either way, you get the same answer. Now, it also works with a minus b squared. The only difference between these two, that one's got a plus, that one's got a minus. Okay? So you could work out the proof like this yourself, just a minus b times a minus b, and you can take a look at that. So here's the problem we're going to look at is 2x minus 5 squared. So if I follow the pattern here, here's my a and here is my b. So this would be 2x squared minus 2 times a, which is 2x, times b, which is 5, plus 5 squared. So this is going to be 4x squared. 2 times 2 is 4, times 5 is 20, so this is minus 20x, plus 25. Okay, and then like I said, you can always, if you don't like to use these patterns, you can always just simply write it out like this and FOIL it. So 2x times 2x would be 4x squared. This would be minus 10x on the outside. This would be minus 10x on the inside. This would be plus 25 in the middle. And so this comes out to be 4x squared minus 20x plus 25. And hey, that matches that. Okay? Alrighty, so here's a couple problems that I want you to pause the video and give a try, and then jump back on and see how you did. Okay, so this one here, this is the a minus b, a plus b. So this is going to be, this is going to end up being a squared minus b squared. If you use the pattern, so that would be 5x squared minus 2 squared. So this would be 25x squared minus 4. Okay, if you just FOILed it, and I like FOIL, so, you know, 5x times 5x would be 25x squared. Outside would be 10x. Inside would be negative 10x. And last would be negative 4. And you combine your like terms, these two cancel out in the middle, and you get 25x squared minus 4. We'll just do that to show that they cancel out. Okay, over here, 2x minus 7, I'm not even going to bother trying to do the pattern on that. Because a lot of people struggle with it. Just go ahead and write it out and FOIL it. So 2x times 2x would be 4x squared. Outside is going to be negative 14x. Inside is also going to be negative 14x. Last is going to be negative 7 times negative 7 is positive 49. So this is going to be 4x squared minus 28x plus 49. And you're done. Okay, here's what you got to do on this one is you're going to use the area model to find the shaded blue area. Okay, so of course what you want to do is you want to take the area of the big square, or yeah, it's a square. It's x plus 3 by x plus 3. You're going to take the area of the square, and then you're going to subtract the orange area, and what's left is going to be the shaded blue area. Okay. So at first that seems really easy because you can start with the area of the big square. That's going to be x plus 3 times x plus 3. Okay, so if I FOIL this, x times x is x squared. Outside is 3x. Inside's another 3x. Last is 9. So that's x squared plus 6x plus 9. Okay. Here's where it starts to get a little tricky. Is you got to figure out this orange area. Now you know that this is x, and you know from here that this is 1. Okay, but you don't know what this is. Okay, there's nothing that says. I mean, it looks like it's 1, but there's nothing that says that it's 1. So here's what I would do with this thing. I would figure out everything that I could figure out on this thing. Legitimately. So let's see. I know that the area of this rectangle right here is going to be 3 times x, because this is x and this is 3. So this is going to be 3x right here. Now, I know that this area right here is 1, or this is 1 by 3, so the area of this is 3. And what else do I know? I know that this is 3, and that's 1, so that makes this 2. Okay, and this is 3, so that makes this 3 over here. So I know this is 6. 3 times 2 is 6. Now, since this is 2, this is also 2, all the way up here, 2 and 2, okay? So this is 2 by 1 right here, so this area is 2. And I don't like having that right there. So we're just going to put the 2 right there like this. Now, this is 1 by 1, so this is an area 1. And this is 1 by x, so this area is x. Okay. Now, I know that, I know this is 1 right here, and I know this is x right here, but I don't know for sure what that is. Oh, I'm sorry, I do know what that is. That's 2. I don't know what this is for sure. And that makes it a little bit difficult. Okay, so what do I know? Well, I know I can figure this out right here. Okay, that right there is x plus 1 times x. Okay, which is otherwise, if I distribute this, this is known as x squared plus x. And that's the whole yellow rectangle right here is going to be that part. And then I happen to know that this is x and that's 1, so this part's x plus 1. So I can take x plus 1 away from that. Okay, so this is going to be x squared plus x minus 1. Those x's cancel out. And I get x squared minus 1. That's the orange part right here. X squared minus 1. Okay. So I've got the whole blue square here. Over here already. That's this. And I know that the orange part is x squared minus 1. So I'm going to go ahead and take this, and I'm going to subtract x squared minus 1 from that. And so this is x squared plus 6x plus 9 minus x squared plus 1. When I distribute this in here. Okay. And then x squared minus x squared is 0. 6x and 9 plus 1 is 10. That's the area of the blue region. That was a little complicated, but we got it figured out. Okay, so now the next thing it says is, hey, what's the blue area when x is 2? Well, that's easy, because all I got to do is take 2 and plug it in here. So that'd be 6 times 2 plus 10 would be 12 plus 10, which is 22. So these are going to be 22 square units. And I'm done with that one. And you know what? I should have my square units on here. That's better. Okay. So that was a hard one, but we got it done. Okay, show how the product of two binomials can be used to model the Punnett Square. So a pink snapdragon, here's my pink snapdragon, has two genes, one white, which we're going to call W, and one red, which we're going to call R, that determine its color. Okay, so the Punnett Square illustrates the possible results, that should say results, there should be no S right there, of crossing two pink snapdragons. So I've got a red-white makes pink, and red-white makes pink, okay? So this right here is going to be, if I get two R genes, one from this would be like the father, this would be like the mother, okay? So you get both red genes, you're going to get a red snapdragon, okay? If I get a red and a white, I'm going to get a pink snapdragon. So this is going to be pink. This one's going to be pink. I'm going to get a white snapdragon if I get a white and a white, okay? So I can look at the picture and I can say 25% of these are going to be red, 25% are going to be white, the other 50% are going to be pink, okay? So how do I model that thing? Well, I can use this. I know that 0.5R plus 0.5W squared is going to be a model for that, okay? So half of them are red, half of them are white. Half the genes are red, half the genes are white. Okay, and I'm going to square that. So what happens here? I get 0.5R plus 0.5W. Let's rewrite that a little bit. Times 0.5R plus 0.5W. Okay, so if I FOIL this, first, outside, inside, last. Okay, so first, 0.5 times 0.5 is 0.25, and I get RR. Okay, outside I get 0.5 times 0.5, that's 0.25, but it's RW. Okay, here I get 0.5 times 0.5, that is also 0.25, and it's WR, but it doesn't matter if it's WR or RW, so I'm just going to write it RW again. And then last, I'm going to get 0.5 times 0.5W, okay, so that's going to be 0.25 WW. Now I can combine my like terms here. Okay, there's my 0.25 RR. Now 0.25 plus 0.25, that's 0.5 RW plus 0.25 WW. Okay, so this shows me 25% are going to be red, 50% are going to be pink, 25% are going to be white. And I'm done. I should probably label this. This is going to give you red. This is going to give you pink. And since white doesn't show up on a white board, we're going to use black to represent white. Okay, so this is 25%. This is 50%. And this is 25%. Okay. So there's your worksheet. I will talk to you guys later. Have a great evening.